Okay, so students, I believe that you are doing great. And let us now understand very well what real numbers are. All along, we have been talking about rational numbers, and then we have also been looking at irrational numbers. But then when we talk about real numbers, what are they? What are those real numbers? So to understand that very well, let us first remember what is a rational number. A rational number. A rational number. So a rational number is a number that can be written in form of A out of B, where B is not equal to 0. So that's what we call a rational number. In other words, it is that number that you can write as a fraction, because when we say A out of B, that is a fraction. And we know that A is what we call the numerator and B is what we call the denominator. So the denominator B, or any number that you have as the denominator, must not be 0. And also A and B must be integers. Let's write it also, that A and B are integers. And I believe that at this time, you all know what integers are, okay? So one more important thing that we have to know as we continue with our lesson of today is what we call irrational numbers. Let's get the definition of an irrational number. So we say that an irrational number is that number that cannot, a number that cannot be written in form of A out of B, where B is not equal to 0 and A and B are integers. So you have A, you have B, and B is not equal to 0, but both of them are integers. But surprisingly, this number will not be able to be written as a fraction. So that is a number that we call an irrational number. But both rational and irrational numbers are real numbers. Let's also indicate that because it's a very important point. We can say that real numbers are both rational and irrational numbers. So when we talk about real numbers, we are talking about the numbers that we use, the numbers that exist. Any number that you have ever seen, let it be a decimal, let it be a whole number, let it be an integer, let it be a fraction, that number, we call it a real number. Okay? But of course, we have seen that real numbers are divided into two parts: rational numbers and irrational numbers. Now, to understand very well what rational numbers and irrational numbers, let's look at this table. Okay. Now, I want you to get your calculator ready with you, and we begin. So in this column, we have number, we have type of number. I told you it can be rational number or it can be irrational number. And then we will look at the result that we are going to get after dividing. Our answer or our result can be what we call a terminating decimal. It can be what we call a recurring decimal. A recurring decimal, you can also call it a repeating decimal. It can be what we call a non-terminating decimal. We have looked at these already, but to remember very well, I will be guiding you as we do our division. I will be giving you the properties, how the number should be, and then you'll be able to tell if a number is terminating, if a number is recurring, if a number is non-terminating, and then you will also decide whether a non-terminating decimal is a rational number or an irrational number. You will be able to tell if a recurring decimal is rational or irrational. You'll be also able to tell if a terminating decimal is an irrational number or a rational number. Okay? So I believe that you are ready with your calculator. So let's begin. So 9 divided by 4, we are getting 2.25. So 2.25 is a rational number. Why? Because we can write it as a fraction. We have a numerator, 9, and we have a denominator. And now we are getting 2.25. 2.25, we call it a terminating decimal. Why? You have the decimal point here. After the decimal point, you have 2.5. You don't have any other number. After the decimal, you have 2 and 5. There is no any other number. So a terminating decimal is that one that after the decimal point, the digits that you have will terminate. In other words, will end. In other words, their number is finite. It shows that, okay, it ends from here. So you can see that the digits after the decimal point, they stop from 5. So it terminates when it reaches at 5. In other words, the digits stop when they reach at 5. So that one we call it a terminating decimal. I hope that is okay. Now, get -3 and 1 out of 8. Divide it in your calculator. What are you going to get? You see that you will get -3.125. You see? And the digits will stop at 5. After the decimal point, the digits stop at 5. You see? We say that this is a rational number because it can be written as a fraction. We have a numerator, which is 1, and we have a denominator here, which is 8. And even you can make it an improper fraction. You get 8 times 3, that is 24 plus 1. You get -25 out of 8. So the numerator will be -25, and the denominator will be 8. So that one is a rational number. Now, what about the type of decimal? You see, the digits stop at 5. Since they stop at 5, we will say that this is a terminating decimal because the digits stop at 5. Okay. Now, get 63 divided by 64 in your calculator. What can you get? All right. You see that you are getting 0.984375. The digits stop at 5. So since you can see that the digits after the decimal point can end or can stop, we say that that is a terminating decimal. And since we have the numerator 63 and we have the denominator 64, we say that that is a rational number. It can be written as a fraction. Okay? Next, get 1 divided by 3. Okay? 1 divided by 3. What do you get? All right. You get 0.3333 repeating. You see that 3 is continuing without end. In other words, we saw that that kind of a decimal, we can say that it is 0.3 and a dot on top of 3. To mean that 3 continues repeating endlessly. So it means that 3 will not stop. It will continue repeating without end. Okay. Now, but it is 1 out of 3. It has a numerator, the number up, and the number down. 1 out of 3. You see, 1 is the numerator and 3 is the denominator. So since this can be written as a fraction, we will say that it is a rational number. But you see the digits after the decimal point do not end. The digits after the decimal point do not terminate. You see, they cannot stop. 3 continues endlessly. So we say that this kind of a decimal, we call it a recurring decimal. Recurring decimal. I told you, a recurring decimal, you can also call it a repeating decimal. I believe you can get that. Now, get negative 123 divided by 99. What do you get? We are getting negative 1.242424 repeating. You see, it cannot end. We have 2424242424 continuing without ending. So that is what we call a recurring decimal. 24242424 is repeating. But of course, since we have the numerator as 123 and the denominator as 99, we say that it is a rational number. Okay? And remember, if you have a decimal like negative 1.242424 repeating, we can write that as negative 1.24, a dot on top of 2 and a dot on top of 4. That is what we call the recurring decimal. Okay. On your calculator, press 22 divided by 7. 22 divided by 7. What do you get? Okay. 3.142857. Again, 1.5 42857. So you can see that these digits are continuing to repeat. 142857, 142857, 142857. It continues repeating endlessly. Since it continues repeating, so we are going to say that it is a rational number because we have a fraction, 22/7. And it is a recurring decimal because 142857 continues repeating again and again. So we are having how many digits repeating? 1, 2, 3, 4, 5, 6. 6 digits repeating and repeating and repeating. So that's why we call that one a recurring decimal. Okay. On your calculator, place 1 divided by the square root of 2. 1 divided by the square root of 2. What do you get? You can get 0.7071006. So this number continues without ending, but there is no pattern of digits that are repeating. You cannot know that it is 7 repeating. You cannot know that it is 7016 repeating. So there is no pattern of a number that is repeating. So this kind of a number is what we call an irrational number. You see that? And remember, we said that for a rational number, it can be written in form of A out of B. And we said that A and B must be an integer. So if you look at the square root of 2, the square root of 2 is not an integer. Remember, we know that an integer, these are the negatives and positives, like 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, like that. So those are integers. So when you look at the square root of 2, square root of 2 is not an integer. So since it is not an integer, it cannot be written in form of A out of B. And remember, B must not be equaling to 0, and A and B must be integers. So since this one is not an integer, the whole of this becomes an irrational number. And because after the decimal point, the digits do not stop, and there is no digits that are repeating in a similar pattern, we say that this one is a non-terminating decimal. Okay, on your calculator, press the cube root of 5. Cube root of 5. What do you get? Okay, that is 1.709975 and many other digits continuing. So again, this one, you see, there is no pattern of digits that are repeating. So that's why we say that it is non-terminating. 2, this one, it is an irrational number because it cannot be written as a fraction. In other words, it cannot be written as A out of B. Okay, we cannot write that as a fraction, so it is an irrational number. Okay, on your calculator, place pi. Press pi. What do we get? We get 3.14159.2 and many other digits coming endlessly. So this one, because there is no pattern of digits that are repeating after the decimal point, we say that this is an irrational number, and so it is a non-terminating decimal. I hope you can understand that. So I know someone may ask the question, okay, we know that pi is equal to 22 out of 7. So why 22 out of 7 is a rational number and pi is irrational number? I need you to note that 22 out of 7, it is not equal to pi, but it is approximately equal to pi. So they are not equal. They have never been equal, but we say that, okay, pi is near to 22 out of 7, but they are not equal. That's why 22 out of 7 is a repeating decimal, but pi is not a repeating decimal. That's why we say 22 out of 7 is a rational number and pi is irrational number. And even when you look at the decimals that you are going to get, when you have 22 out of 7, you are having 3.142857 repeating 142857, 142857, 142857. Now, but for pi, you are going to get 3.141592 and many other digits coming without repeating. So they are not equal. But we always use that as an approximate to say that, okay, pi, because you see that it is 3.141 and 5 can round 1 to become 2. And when you get 22 out of 7, you are getting 3.142. So it's kind of, they are near to each other, but they are not equal. So get to understand that 22 out of 7 is a rational number, but pi is irrational number. I think you can get this point very well. Okay. Now, one more thing that you need to note is that sometimes you may still be confused that if I have a number like 2, so this number, is it a rational number or it is irrational number? But when you look at this number 2, we can write it as a fraction. How? You get 2 out of 1. 2 out of 1 means that 2 is the numerator, 1 is the denominator. So it can be written as a fraction. So 2 is a rational number. In other words, all whole numbers, in other words, not whole numbers only, but all integers are rational numbers. All integers are rational numbers because they cannot be, they can be written as a fraction. Even if you have, let's say, negative, let's say negative 9. Negative 9 can be written as negative 9 out of 1. So still that is a fraction. So that's why it is a rational number. Another thing, you may say, okay, what about the square root of 4? A square root of 4 is rational. Why? Square root of 4 is 2. You see? And 2 can be written as a fraction, 2 out of 1. So that's why the square root of 4 is a rational number. In other words, all square roots of perfect squares, all square root of perfect squares are rational numbers. Let's say square root of 9, square root of 16, square root of 36. All of these are rational numbers. Also cube roots of perfect cubes. Let's say cube root of 8. We know that the cube root of 8 is 2. you know that the cube root of 27 is 3. So all of these are rational numbers because 2 out of 1, the cube root of 8 is the same as 2 out of 1. 2 out of 1 is a fraction, the same as the cube root of 27, which is 3. 3 out of 1 is a fraction. So all of these are rational numbers. But square roots of other numbers that are not perfect squares, let's say the square root of 2, let's say the square root of 3, let's say the square root of 5, let's say the square root of 6, all of these are irrational numbers. The same applies to cube root of 2, cube root of 3, cube root of 5, cube root of 6, cube root of 7, cube root of, but cube root of 8 is 2. So cube root of 8 is not irrational number, but it is a rational number. So that point, you need to understand it very well. Don't get confused. So that's why we are doing it like that. Okay. Now, from what we have looked at today, I will ask you these few questions. Number 1, is a terminating decimal a rational number or irrational number? Terminating decimal. Is a terminating decimal rational or irrational? Is it rational or irrational? I want your answer in the comments, okay? Now, is a recurring decimal, is it rational or irrational? Another one, is non-terminating decimal, is it rational or irrational? Okay. So I would like you to answer those questions. I will then understand that you have understood. Okay. So in summary, when we try to summarize this very well, we can say that, okay, so when we have real number, we can divide it into 2. We get rational, and then we get irrational. Rational number and irrational number. And then rational number, we will have terminating decimal, and recurring decimal. And then irrational number, we say we have non-terminating decimal. Yes, so I believe you have understood what we call rational numbers and what we call irrational numbers. So all of those are real numbers.